next up, we are given the ammonia molecule and we'd like to determine whether it's polar or non-polar and just explain our answer based on the electronegativity of nitrogen and hydrogen atoms. And so before we begin with the electronic or molecular geometry, we need to first figure out the Lewis structure. And so we begin by counting the valence electrons. We have 5 from our nitrogen and 3 by 1 because of the hydrogens. And so that's going to add up to give us 8 electrons to mess around with. Let's put our nitrogen as a central atom, because hydrogen can't be it, and surround it with our 3 hydrogens. So now we have a total of 6 electrons in the bonding pairs and 2 more electrons to put somewhere. We can't put them on hydrogen because it simply doesn't have the space. So it makes most sense to put them on the nitrogen. And now, since the valence electrons are all taken care of, let's double check on our formal charge. And so for the nitrogen, we will get 5 minus 3 minus 2, giving us 0 as we expected. And for the hydrogen, it will simply be 1 minus 0 minus 1, giving us 0 as expected. So our valence electrons are all okay, and our formal charge is okay. And so this is the correct Lewis structure. Now, based off of that, we can move on to finding the molecular structure. So we begin by counting the steric number. And that's the number of atoms or lone pairs attached to our central atom. And so we have 3 bonding pairs and an additional 1 lone pair. And so that's going to give us 4 as the steric number. And its notation will tell us how many bonding pairs there are compared to lone pairs, and that's going to be AX3E1. And so now we're going to pull up the VSEPR chart. Okay, and so we go to the total domains / steric number, and ours is 4 as we've determined. And then we will begin accounting for the number of lone pairs. So we have 3 bonding pairs and 1 lone pair. So its electron geometry will be what we first encountered, and that would just be the fact that it has 4 groups attached to it, so it's tetrahedral. And its molecular geometry accounts for how many are bonding pairs or lone pairs, and that is going to be trigonal pyramidal. And then let's go ahead and draw that out. Okay, and so now we can figure out the polarity by drawing out our dipoles and then seeing if they all symmetrically cancel out in order to give us a net dipole moment of 0. That would mean that it's nonpolar. And so the more electronegative one between nitrogen and hydrogen is going to be nitrogen. So just point all of those dipoles that way. And then between lone pairs and whatever atom it is, the lone pairs will have the higher electronegativity, so this will point upwards. And so now when we add all of these up, the angular components of these dipoles for the hydrogen will all cancel, yielding one vector pointing up. And then we also have the dipole pointing up towards the lone pair. Clearly these two will not cancel and hence will not be 0. What this now means is that NH3, ammonia, is going to be a polar molecule due to its non-zero dipole moment that is caused by the lack of symmetry in the molecule. And that's it for this one. So I've already made the drawing to support our answer.